What is an exoskeleton? And do you know the difference between a vertebrate and an invertebrate? I'm Alex, and this is Science at 6 with Cambridge Science Centre. Today we're going to be reviewing last week's Creepy Crawly Challenge, answering your questions on biodiversity, and Mario is going to be doing some kitchen construction. And we will, of course, also be setting you a brand new challenge to tie in with this week's theme. You can find out where to get our activities in the description below, and you can email us your results and questions to openupscience@cambridgesciencecentre.org, or you can tag us on social media. Last week's theme was biodiversity, the variety of life in a given area. And last week's challenge was to build a bug hotel. There's no set way to make a bug hotel, so you had the chance to be really creative, make something unique, and it's a great way to reuse and recycle old bits of wood, tiles, cardboard, and more. So let's take a closer look at the visitors you may have had at your hotel. You may remember from last week's episode, we talked about how you can group similar organisms together. You can in fact split all animals into one of two groups, vertebrates and invertebrates. But what are vertebrates? What are invertebrates? Well, vertebrates are animals with backbones and skeletons inside their body. Invertebrates, however, don't have backbones and don't have skeletons inside their body. For example, Homo sapiens, that's you and me, have skeletons inside their body, and we have backbones too. Ants, however, are invertebrates. They don't have backbones, and instead of an internal skeleton, have something called an exoskeleton. So exo means outside, and ants have a hard outer skeleton, exoskeleton. I'm going to go through some of the creatures that you might have had staying at your hotel, and I want you to have a think and work out which ones you think are vertebrates and which ones are invertebrates. So pause after each one if you want a little extra thinking time. So, first one, slugs or snails, vertebrates or invertebrates? The correct answer is invertebrates. They have no internal skeletons and no backbones, so well done if you got that right. Next one, bees, buzzing bees, what do we think? Bees are invertebrates, so again they have no backbones and no internal skeleton. Final one, hedgehogs, vertebrates or invertebrates? They are in fact vertebrates, so hedgehogs, just like Homo sapiens, just like us, have a skeleton internally, inside, and they have a backbone as well. Other invertebrates that might have stayed at your hotel include spiders, millipedes, woodlice, ladybirds and beetles, and if you're lucky, one other vertebrate you might have had staying would be toads. And hopefully you managed to see at least one of each of these different species. So I hope you learned something there about the animals that live in your garden and the green spaces around you. But what other questions did you at home have about biodiversity this week?
Hello everyone, my name is Mia and I'm going to be answering some of the questions that you have sent in to us this week. Our first question comes from Lucy, aged 10, who asks, what is the biggest animal you get in the UK? Well, Lucy, the largest animal you can get in the UK in the wild is a red deer. From their feet to their shoulders, these magnificent creatures can reach around 1.2 metres or 4 feet. And they grow around 2.5 metres long from head to tail. The male deers, or stags, have enormous branching antlers. As the stag gets older, it grows more of these branches, and the antlers can grow to around 1 metre long. Our next question comes from Tina, age 8, who asks, are different dogs different species? That is a really great question, Tina. There is a massive variety of dogs, from big fluffy huskies to small and short dachshunds. However, dogs are generally thought of as being part of the same species, containing different breeds. It's actually really hard to define a species, but one of the most common ways is the biological species concept. This defines a species as a group of animals that can mate and reproduce to make offspring that can also reproduce, and all dogs can do this. This is why you can get crossbreeds of dogs, like a Labradoodle, which is a cross between a Labrador and a Poodle, or a Dorgie, which is a cross between a Corgi and a Dachshund. These crossbreeds of dogs are fertile, and that means they can go on to have pups of their own. Great questions, everyone, and we really love receiving them.
Thank you everyone who sent us their questions for this week. Keep sending us your results and questions to openupscience@cambridgesciencecentre.org or get hold of us on social media. Now, last week's Bug Hotel Challenge actually ties in really well with our theme for this week, which is structures. A structure is something that is built or arranged in a definite way to provide support. There are structures in nature, like a spider's web, and there are man-made structures, like a bug hotel. Mario is going to show us now how to make a bridge structure, but with a twist. Usually, when you think of the materials you would use to make man-made structures, you might think of bricks and cement for a house, or steel for a bridge. However, Mario is going to be using a very different material altogether. In fact, you can eat this material. Let's take a look.
Today we're going to be doing some chocolate welding and testing how strong our structure is. So what you need first is a jig to place your bits of chocolate into, and also 4 pieces of chocolate with nice strong ridges. We start by taking 2 of our pieces of chocolate, melting them on a hot bottle. Melting the edges. We place that inside our right angled jig. And let's put that in the fridge for about 20 minutes to make sure it's nice and set. Once your pieces have set, you will end up with 2 sections that look like this, which will form half of your box. So what you then need to do is melt the edges of both of these in order to form the rest of your section. And very carefully place these inside your jig. Now is the time to take care to get the edges to line up to form a nice box section. Again, if we put this into the fridge, we'll leave it out for about 20 minutes to make sure it's nice and set. Once it's set, you should end up with a nice box section, a bit like this. So now we need to test how strong our bits of chocolate are. Now we're going to test a single piece of chocolate to see how much weight it can hold. I have these blocks here which are about 50 grams each, but you can use whatever you like at home. So here we go. 50 grams, 100 grams, 150 grams, 200 grams, 250 grams. A single piece of chocolate can hold about 250 grams, but it might be slightly different for you. Now, let's test our box section. We'll start off with 250 grams because we know that that's what our single sheet of chocolate could hold. $500 grams, 1 kilogram, 1.5 kilograms, 2 kilograms, 2.5 kilograms, 3 kilograms, 3.5 kilograms, 4 kilograms. So our box section could hold just under 4 kilograms, which is significantly more than that of our single piece of chocolate. So, why is our box section so much stronger than a single piece of chocolate? Well, it's a bit like a ruler. If you try and bend a ruler from each end, or even from the middle, it will start to bend and eventually it will snap like our single piece of chocolate. But if you turn it on its side or straight on to try and exert a force on either end, it's really, really difficult as it's taller and thinner. And what happens in our box section is just the same. We have 2 taller and thinner pieces as well as our surface on top to absorb a lot more of the forces that were being placed on our box section. And the best thing about this experiment is that once you've finished it, you can also eat it.
Awesome. Thank you, Mario, for a detailed breakdown of how to do this at home with some fun ideas for what to make thrown in too. Just check the description below for an activity sheet. You might also like to have a go at our challenge this week. So we want you to have a try at making a bridge using tightly rolled pieces of paper and some staples and sticky tape to put the different rolls of paper together. Once it's finished, test it out. How much weight can it hold? Can a toy car make it all the way across without falling off? Whatever you decide to do, however you decide to test it, send us a picture and don't forget to send us your questions too. We'll take a look at them next Monday on Science at 6. Thank you very much. Bye-bye.